Imagine living on a planet where an entire year passes before you could finish a single work shift. Not months, not days, just 7.7 hours. That is the astonishing reality of GJ 367b, a small world orbiting a red dwarf star roughly 31 light-years away. NASA's current exoplanet catalog lists it as a terrestrial planet with an orbital period of about 0.3 days, and detailed observations place its year at approximately 7.7 hours. But the strangest part isn't simply how fast this planet moves. It is what the planet appears to be made of. Because GJ 367b is not a giant gas world racing around its star. It is a tiny, rocky planet, and it may be one of the most extreme planetary remnants ever found. To understand just how strange this is, picture our own solar system. Mercury is the fastest planet around the Sun. It takes about 88 Earth days to complete one orbit. GJ 367b does the same basic thing in less than 8 hours. That means while you were eating breakfast, the planet could have already traveled around its star. And before an Earth day was over, it could have completed roughly 3 complete years. But there's a reason it can move so quickly. GJ 367b is incredibly close to its star. NASA places its orbital distance at only about 0.007 astronomical units, roughly 1% of the Earth-Sun distance. At that distance, gravity and orbital motion create an environment completely unlike anything on Earth. The planet circles a small red dwarf, an M-type star, and because the orbit is so tight, the planet is bombarded by intense radiation and heat. Scientists estimate that its equilibrium temperature is around 1400 degrees Celsius, depending on the assumptions used. That is hot enough to transform the surface into something almost alien beyond imagination. But then researchers discovered something even more surprising. GJ 367b is only 72% the radius of Earth and roughly half Earth's mass, yet its density is extraordinarily high. The measurements suggest that a huge portion of the planet could be iron. In fact, models indicate that its iron core may occupy around 86% of the planet's radius, an astonishing figure compared with Earth. So what happened to the rest? Where did its rocky outer layers go? One possibility is that this planet was once much larger. Perhaps it formed farther away, with a thick, rocky mantle surrounding a metal-rich core. But over immense stretches of time, repeated heating and violent impacts may have stripped away much of that outer material. What remains could be the exposed heart of a world, a planetary core racing around a star at impossible speed. And that raises the biggest question of all. How can a planet survive in a place this extreme? Because at only a fraction of Mercury's orbital distance from the Sun, GJ 367b is living on the edge of what a rocky planet can endure. And scientists aren't just studying it because it is strange. They're studying it because this tiny world may contain a clue to one of the greatest mysteries in planetary science: how planets are destroyed, transformed, and sometimes reduced to almost nothing, while their cores survive.
The answer may be hidden in the planet's atmosphere, or rather, in the fact that it probably has almost none left. Researchers studying GJ 376b's host star found that the planet exists in an environment where high-energy radiation can strip gases away extremely quickly. A 2024 study concluded that any primordial or outgassed atmosphere would likely have evaporated long ago. That changes the picture completely. GJ 376b may not be a world with an atmosphere protecting its surface. It may be a world where the surface is simply simply exposed to space. Imagine standing there. There would be no familiar blue sky, no oceans, no forests, no clouds drifting overhead. Instead, you would be looking toward a nearby red star, while the ground beneath you endured enormous amounts of heat and radiation. And the planet's year would continue racing by. Every 7.7 hours, another orbit would be complete. NASA currently lists the orbital period as about 0.3 Earth days, with the planet traveling only about 0.0071 astronomical units from its star. But there is an important detail. A year this short does not mean the planet is spinning rapidly like a carousel. The year measures how long it takes GJ 376b to travel around its star. Its distance from that star is what makes the orbit so extraordinarily fast. The closer a planet is to its star, the stronger the star's gravitational pull, and the greater the orbital speed required to remain in orbit. GJ 376b is essentially locked into a relentless gravitational race. And its strange interior makes that race even more fascinating. Scientists estimate that its iron core occupies roughly 86% of the planet's radius. For comparison, Earth's core is nowhere near that proportion. This has led scientists to consider several possible explanations. Perhaps GJ 376b formed with an unusually iron-rich composition. Perhaps enormous collisions stripped away much of its rocky mantle, or perhaps intense stellar radiation helped remove material over billions of years. We still don't know which explanation tells the complete story, and that uncertainty is exactly what makes this planet scientifically valuable. Because GJ 376b is not simply an exotic curiosity, it is a natural laboratory. A place where astronomers can test ideas about how rocky planets form, how their interiors evolve, and what happens when a small world is pushed dangerously close to its star. And there is an even bigger mystery. If a planet can survive this close to a star for billions of years, where is the true limit? How close can a rocky world get before its atmosphere disappears? How much of its surface can evaporate? Can a planet lose almost its entire outer layer and still remain gravitationally intact? GJ 376b may be giving scientists part of that answer. It is small, it is dense, it is almost certainly nothing like Earth, and yet it survived. For billions of years, this strange little world has continued circling its star at breathtaking speed, completing year after year while an Earth calendar barely moves. 7 hours, then another year. 7 more hours, another orbit. A planet trapped in a permanent cosmic sprint. And perhaps the most incredible thought is this. When we look at GJ 376b, we may not be seeing what a planet normally looks like. We may be seeing what is left after a planet has been pushed to its absolute limits. A tiny, iron-rich world racing around a distant star, with its atmosphere possibly erased, its rocky exterior dramatically reduced, and its year compressed into less than 8 hours. The universe does not need to invent impossible worlds. It only needs to push ordinary physics far enough. And somewhere, 31 light-years from Earth, GJ 376b is showing us exactly how strange that physics can become.